I'm actually here with a presentation, and I'm here to talk about, ostensibly, your hardware knowing a little bit about its environment. So just to start this off, I know that we're after lunch, and everybody's probably a little bit dozing off. So I want to start out with a little bit of exercise by having everybody raise their hands for a whole bunch of questions, which will help me gauge my audience a little bit. How many people here like JavaScript? Almost everybody here. That's great. Okay, how many people here like Node.js? That's pretty good too. Great. How many people here like hardware? Awesome. How many people here have actually developed against hardware? I'm losing a little bit of the crowd, but that's good. I'm here to help change that. Because the next question is, how many people here have had one of these mornings? Come on. The where the fuck am I, what's going on? This is how I think of code. This is how most code is. It really doesn't know what's going on. It thinks, I have this little box. What's in this box? Well, what happens if we take the box away? What happens if we expand that? We have the ability to do that. How many people here have seen one of these? It is a Raspberry Pi. How many people here have one of these? Great, that's about half of you. How many people know what these headers are? Okay, so for those of you who don't, this is called a GPIO bus, general purpose input output. You can use this to talk to the outside world. It also has this really awesome thing called a USB bus, also quite useful for talking to the outside world. So how do you do that? You connect things. So up here, I have a whole bunch of things connected. I'm going to have to be a little bit careful, but how many people know what this little thing in my hand here is? Can you see it? It's a breadboard. I can't. If I hold it up any higher, I'm going to have everything fall apart into a massive breakage of chaos and destruction, and we just can't have that. So I could sit here and tell you all about all this, but really I'm here to teach you to fish. And part of teaching to fish is telling you about some really cool concepts. How many people know about datasheets? I know this is a really scary word, hence the scared cat. Datasheets are the things that tell you all about the hardware that you're going to be talking to, how it communicates, what protocol it uses, and how everything comes together. I know Ward was fantastic in showing you all the scary little diagrams when he was talking about datasheets. I'm not going to show you anything that scary. I'm going to show you things that are a little bit simpler, this one's a real stretch, the demo cat. So let's go ahead and break into a little bit about what's going on, a little bit about demos, and let's really hope that I can still talk to my Raspberry Pi. Yes, I can. Awesome. Can everybody see this? Are we down enough to? Great. So I have a couple pieces of hardware hooked up to this, using a couple of different connections and protocols. The first one that I want to show you is an awesome little tiny GPS unit, which, let's see if I can gracefully get this up without breaking anything. Little tiny thing in my hand here. This thing is using USB to UART. How many people know what UART is? All right, I'm losing a little bit of my audience, but UART is pretty much your TTL communication, your serial communication, sending bytes back and forth, bits back and forth, very, very cleanly. So what we're going to do here is there is a protocol on top of the UART called NMEA. Honestly, I don't even know what NMEA stands for, but we're just going to go for it. So NMEA is the piece that reads from the GPS, breaks it up into the parts and pieces, and tells us what's going on. So if we were to take a look at this, here is something that's simply requiring an NMEA module connecting with Node serial port and parsing it. So I'm going to show you what these packets actually look like after they're parsed, provided my keyboard ever catches up from going the hard way. All right. You guys have been having network problems, I assume? Yes? No? Yes? Yeah. That's me too. So I'm going to switch to something else here, also USB to UART, because the Raspberry Pi has a serial port built into it. This will be not quite as cool. I'm hoping that I get my network back so I can show you an actual browser demo. No, I have to have them both tethered together, but come on. Let me just go ahead and get a new. How many people have used Screen to connect to a TTY? All right. We're going to do that right now. Where we are logged in. We're going to edit anyways because we're already blocked. So let's go ahead and take a look at this data coming out. Which is doing nothing. Awesome. Okay. I can go right past this. Demo fails are awesome. So we also have how many of you have heard of a really cool piece of hardware called a 10DOF, or 10 degrees of freedom? All right, we're down to about 4 or 5. So what this is, and I'll actually show you the cool little thing here in a minute. It is a very awesome piece of hardware using something called I2C, which is another of these fantastic bus protocols to communicate 4 different chips: an accelerometer, magnometer, a very nice bus. So what we're connecting up is power, ground, SLA, and SLC. Those are the 2 one-wire pieces that, or not one-wire, I2C pieces that you connect together that actually get you to communicate with the device. So on this device, if you take a look here, I'm using this module called I2C, which compiles nicely. So what we're doing here is we're doing a wire scan, and we're essentially asking the device through the I2C bus, what addresses do you have? So let's go ahead and run this. And it is telling us that it's finding a device at address 30, a device at address 83, a device at address 105, and a device at address 119. I know this doesn't really tell you much, but since I actually know what the chips are, I go and look at these crazy things called datasheets. So one of the things here is a motion sensor. My goal is to make the word datasheet be a lot less scary and a lot more user-friendly. But not all of these are as friendly as they could be. As you see here, there's all this stuff. Looks like probably 42 pages of absolutely crazy stuff and how to hook everything up. And we're going to make it to the same diagrams that Ward was showing us, the SPI timing diagrams, that are a little bit more than what we actually care about, since we have a bus in front of us, this I2C bus that's doing the abstraction for us. So we're just going to go ahead and fast forward here until we find more of these timings, until we find this. So let me scroll a little bit so you can actually see it on the screen. So these are the commands that we're actually sending to this gyroscope here to ask, who am I? Which it should respond 0x53, which if you read binary, that should be extremely obvious to you. And it has all these other great things that we can ask for. So what do we do with this? Well, we have code. And because code is awesome, and I did hear somebody earlier complaining that they hated presenters that just sat and showed code, but you know what? I like code. So I at least want to show you what some of this does. So gyroscope here. We are writing bytes as we init. We're writing the who am I. We're checking for 0xD3. If it's the correct device, which it should be because we actually know what device it is, it goes ahead and turns off the power down, enables it, and tells to get ready for interrupts and get ready for reading. Go ahead and read it. We read the bytes. We do the math, make sure it's signed. Really bad anti-pattern here, but eventually we call back with an X, Y, and a Z. So what does that end up doing? And what does that end up looking like? Well, that's simple. As soon as I can find my terminal. If all goes well, then we have an actual gyroscope with data coming out that gets disconnected because my screen session goes out when I accidentally get. So we're pretty stable right now. We're really not moving. We have a magnometer as well. So let's take a look at that code. Which is an HMC 5883L, which if we go look at our data sheets over here, an HMC 5883L, which is another really sort of long, crazy data sheet that the things that we care about are way down, 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 because while I admire Word getting so low level with bit hacking, I don't really want to go there. So we have some configuration registers, some data output, and some identification registers that we can read from. Obviously, the configuration and mode are read-write. Everything else is read-only. So what does that mean? We init, we select the mode register, which is essentially turn on, power up, be ready to go, and then we get the data. In this case, we are actually able to just read all 6 registers at once, figure out everything, once again, check, make sure that we're signed, do the math, return the numbers. Not a number, this is the output and then the math that's happening on it. There we go. The degrees that we are facing. Wow, look at that. Just like it's supposed to work. Which reminds me, I'm going to take a break since we're having such good luck with things working. Let's see if we can get output from the GPS. Denied. All right. No, it would be, I'm outputting all the packets, so the one that was getting great connections back there and was giving me all of the, yeah, that's how it works. So let's go back to these sensors. And we also have an accelerometer, which once again, going to go ahead and demo here and take a look at. This, I happen to know, is an L3G 4200D. Let's go take a look at that data sheet here. That's the wrong one. That's the wrong one. Oh, it's an ADXL. Sorry, my bad. ADXL 345, right here, accelerometer. Let's take a look at the data sheet. What does it tell us? All sorts of crazy timing diagrams. And the device ID, and all the data that we need to get. Power control, data X0, data X1, least significant, most significant, actually it's most significant, least significant, and everything else. So let's go ahead and take a look at this. And we're getting data. Should drop it down, it should stay fairly stable, very little drift. Fantastic, that's what we were looking for. So, to me, having the ability to have your software understand its environment, know more about its hardware, really allows you to do really cool things. You saw yesterday the copters flying around. Why not build your own? I am. It's exactly why I have the hardware, which, as I promised, I wanted to show you all of that and more on a chip this big. $14. Highly recommend picking one up. Highly recommend for $14 playing around with it because it cannot be beat. And any questions? What is that chip? 10 DOF, 10 degrees of freedom. Saw another hand, or is it the same question? I find my sensors a mix of SparkFun, which SparkFun every Friday has SparkFun New Product Friday. So I always have a really exciting thing to look forward to on Fridays, or eBay, or Newark. The three really great places to get miscellaneous sensors. These cannot be used with beer, but you can use a one-wire temperature probe. There are also magnet-based flow control that will actually tell you how much liquid is going through, though the cheaper ones, I'm not sure I'd want to send beer through. They're kind of cheap plastic. Yes. So I2C is this great protocol that allows for a ton of things available from an address. So on the I2C bus, each chip is essentially assigned an address. You can query it. You can send very, what's the word I'm looking for? Straightforward byte requests to. They'll respond. They'll send back byte responses, either 1 byte or 6 byte or 10 byte, however many bytes they're supposed to do. It's a fairly open protocol. Each device is mapped to an address. One wire, on the other hand, is a little deceiving. It's actually 3 wires or 4, depending on how you can configure it. You can configure it in slave mode. You can configure it in non-slave mode, which is the multiple wire. And each chip is assigned its own UID. I think there's 65,000 that you can have on one bus. And you send a request, and they just sort of chain all the way through, each responding one by one. There's no real ability to say, you over there, what's your temperature? Any other questions? All right, that's all I have.